Hey guys, Miss Fearon here. Welcome to Unit 7, Note 7. Today we're going to go ahead and we're going to look at probability with a combination or a permutation. So in order to go ahead and do this, we need to determine or think back and remember what are our combinations and what were our permutations. So when I'm talking about a combination, I am talking about when order is not important. It's not important for a combination. So when you're trying to determine if something's a combination, you're going to look for those keywords again. We're talking about groups, we're talking about pairings, we are talking about teams. Those words are going to clue us in to the fact that it's a combination, because it doesn't matter how I pick you to put you in a group. You're in a group in the end. When we are looking at combinations, remember that is our NCR. That's going to be n factorial divided by n minus r factorial. And then we have that extra r factorial. N is our total. Don't forget that. N is the total. And then r is the number we're picking or we're choosing. Okay, so permutations then is when order is important. So keywords are going to help us determine if it's a permutation is when we're talking about arrange. When we arrange something, if we rank something, if we line something up, so line up. If you're talking about a placement, so first, second, third. If you are talking about different jobs, like a president, a vice president, and a treasury, those things order matters. So we're looking at a permutation, which is going to be NPR, which gives us the n factorial divided by n minus r factorial. N and r are still the same thing, determining if combination or permutation. So n is the total, r is the number we're picking. So let's go ahead and look at example number 1 here. I have a combination bike lock that requires a 3-digit code made up of the digits 0 through 9. No number can be used more than once. So part A is asking me how many different combinations are possible. So I'm going to look at this as a combination or a permutation. And since I'm looking at a 3-digit code, when I put codes into things, order matters. Anytime you put in your iPad code or your cell phone code, it matters the order you put the numbers in. So this is going to be a permutation problem. So I'm going to have 10 total digits, and I'm going to pick 3, or 10p3, which is going to give me 10 factorial divided by 10 minus 3 factorial. So I'm going to get 10 factorial divided by 7 factorial. So I'm going to end up going 10 times 9 times 8, and I'm going to stop because the 7, 4, 3, 2, 1, or 7, 6, 5, 4, 3, 2, 1 will all cancel out. So when I do 10 times 9 times 8, I end up with 720 different ways. So what we actually just found there, this is the total ways I can have all those digits and only pick 3 of them. That's my total. So part B now is asking what is the probability that all the digits in the code are odd. So we're looking for probability. And if you remember, when we're looking for probability, probability is a decimal or a fraction where it's our want or our successes divided by our total. So we're actually going to use that total that we just found for these problems. So first thing I need to find is what I want. Well, I want the odd numbers. So I have to figure out how many odd numbers do I have, and then how many do I want to pick. So odd numbers, 0 through 9, are 1, 3, 5, 7, and 9. So there are 5 of them. And I'm going to pick 3 of them because I still want 3 for my code. So that's going to give me 5 factorial divided by 5 minus 3 factorial. So I'm going to get 5 factorial divided by 2 factorial. So I'm going to get 5 times 4 times 3. Stop there because the 2, 1 will cancel out. So when I do this, I get 60 different ways that I can get an odd number. And remember, the odd number is what I want. So this is my successes or my want. This is what I want. So I have to now create the probability or that fraction. So I'm going to do what I want. So 60 out of the total number of ways, 720. And that's the probability of getting an odd number. So when I do that in my calculator, I get 0.083. So looking at part C here, what is the probability that the first digit is 3? So again, probability is my want divided by my total. So we know we're going to use the total from part A again. We have to figure out how many ways can I get what I want, and I want the first digit to be a 3. So if I look at this 3-digit code, this one has to be a 3. After that, I'll take any number, and then I'll take any number. So how many 3s are there? There's only one 3. Then from there, if I took that 3 away and put it there because I can't use it more than once, then there's only 9 options left for the next one and 8 options left for the last one. So when I multiply this out, I get 72. And remember, this is my successes or my wants, okay? This is what I want. I'll be happy if these 72 ways will give me exactly what I want to make me happy. So now I still need to find that probability though, because it's asking for what's the probability. So when I do this, the probability of the first being a 3 is the successes, 72, divided by the total number of ways possible, the 720. So when I do that in my calculator, I get 0.1. So our last thing here is part D. We are looking at what's the probability that the code is 1, 2, 3. So again, we're looking at a probability, so we're doing a fraction. I have to figure out how many ways are going to make me happy. Well, I want the code to be a 1, 2, 3. So the first one has to be a 1, the second one has to be a 2, and the third one has to be a 3. There's only one way for me to get a 1, there's only one way for me to get a 2, and there's only one way for me to get a 3. So 1 times 1 times 1 is going to be 1. So there's one way for me to be happy to get that 1, 2, 3. And then divided by the total number of ways, 720. Put that in your calculator, you get 0.001. Let's go ahead and look at example number 2 here. I have a word processing program that requires a user to enter a 7-digit registration code made up of the digits 1, 2, 4, 5, 6, 7, and 9. Each number has to be used, and no number can be used more than once. Part A asks how many different registration codes are possible. So we want to figure out how many total codes are possible. So I have 7 different spots, and I need to fill them up. So for the first spot, I have 7 options. Last one, I have 6, because I can't use them more than once, so I only have 6 there. Now I'm going to put one down as 5, 4, 3, 2, 1. And again, that's because no number can be used more than once. We can't use a number more than once. So this is 7 factorial. So when we plug that into our calculator, we end up getting 5,040 total codes. There are 5,040 different codes that we could come up with. So that's going to be my total. Remember, we found the total options. So now for part B, we're looking at what is the probability that the first 3 digits of the code are even. So let's look at this code again here. I have a 7-digit code, 1, 2, 3, 4, 5, 6, 7. I need the first 3 of them to be even. The last ones will be odd then. So when I need an even number, how many total even numbers do I have? Well, if I look up here, I have a 2, a 4, and a 6. So I have 3 even numbers. Now when I use one, I can't use it again, so now I only have 2, and then I only have 1. So now we're going to go into our odd numbers and see how many odd numbers we have. Well, now we have 1, 2, 3, 4 odd numbers, so we're going to start with 4. Once we use it, we can't use it again, so we have 3, 2, 1. When I plug this into my calculator, I get 144 different ways that I can get the first 3 digits of the code to be even. But this is asking me for the probability. Remember, probability is going to tell me I need a fraction then. So I'm going to do the ways that'll make me happy, or the successes, and it'll make me happy if I have the first 3 digits be even. So there's 144 ways to make me happy out of the total ways or total codes we have available. So 50, 40. When you plug that into your calculator, you're going to get 0.029. So example, or part C here, what is the probability the first digit is 1? So I'm still looking at the 7-digit code, 1, 2, 3, 4, 5, 6, 7, and I need this one to be a 1. This one has to be a 1. So there's only one 1 in that list. So now once I put it there, I can't use it again. So now I only have 6 options, then 5, 4, 3, 2, 1. plug that into your calculator, you end up getting 720 different ways that you can make a code where the first digit is 1. And since we're looking for probability, again, we have to do the things that we want. So I want the first digit to be 1 divided by the total different codes or possibilities we have. So when I plug that in, I get 0.143. So last part here, part D, what is the probability that the code is 1, 2, 4, 5, 6, 7, 9? Well, if we were looking at that, we know that the first one has to be a 1. 1, 2, 3, 4, 5, 6, 7. This has to be a 1, a 2, a 4, a 5, a 6, a 7, and a 9. There's only one way for me to get a 1. There's one way for me to get a 2. Same for all of these. There's only one of each of these. So 1 times 1 times 1 times 1 times 1 times 1 times 1 is just 1. But now again, since I'm looking for probability, we're going to do one way out of the total codes that we have, so 50, 40. And that's going to give me 0.0002.